Okay, so here's part C.
Well, if
Could they both be right triangles?
with integer side lengths.
With integer side lengths. So this would be A, B, C, and this would be
A plus 1, B plus 1.
A plus 1, B plus 1,
And C
B
plus
plus
1.
1. Okay, so how can we figure out if these could both be integers? What do we know about this triangle?
Well, they're similar right triangles.
How are they similar?
Well, they may not be similar.
What do we know about this triangle? What's the only thing
It
we know
has
about
integer
this?
side lengths.
Okay, what else?
It has a right angle.
Yeah, which means what?
Which means we could use the Pythagorean theorem.
Okay, so go ahead.
So, should we use the Pythagorean theorem?
I'll let you decide.
Well, so we need to find, we have integer side lengths
Uh-huh,
in a right triangle.
okay.
So, what does the Pythagorean theorem tell us?
Yeah.
It just says c squared is a squared plus b squared.
C squared equals A squared plus B squared. That's really the only thing we know, plus that these are integers.
Yeah.
What would have to be true over here if this was a right
Well,
triangle?
a plus 1 squared plus b plus 1 squared is c plus 1 squared.
Okay, so the question is, could this ever happen? So we can expand this side. We're not gonna have a lot of room to do that, but it's gonna. What is it when I expand this?
So it's a squared plus 2a plus 1,
Plus,
b squared plus 2b plus 1.
is it 2b or not 2b? Ah, and this we're wondering, could this ever equal c squared plus 2c plus 1?
Well, since we know that this plus this equals this,
Yep. So
that means
we can just erase those. A squared plus b squared already equals c squared.
it means 2a, so that means this plus this equals this.
Okay, that would mean we would have to have 2a plus 2b would have to equal 2c minus 1.
But these all have ones in them.
Yeah, so I took the 2 on this side and I subtracted it from here, so I have 1 minus 2, which got me the minus 1.
Minus 1.
Okay.
2a plus 2b equals 2c minus 1.
Or we could divide by 2 and say a plus b equals c minus a half.
Well, but this can't ever happen
Why not?
because these are all integers,
Uh-huh.
and this is saying a plus b is not an integer.
Ah, okay. High five, good observation. For this to be true, a plus b would have to equal c minus a half, but c is an integer, and a and b are integers.
So that doesn't really make sense because 1/2 isn't an integer.
1/2 is not an integer. So, we can't have a, b, and c be integers, form a right triangle, and have a plus 1, b plus 1, and c plus 1 also form a right triangle. That's a cool thing we just learned. I never knew that before.
Yeah.
Okay, because maybe it would have been some like crazy right triangle with 100-digit numbers, and it somehow magically all worked. But it turns out
Yeah.
Never.
it never works. But now let me ask you another question, a different question. How could we have seen the same thing without dividing by 2? Okay, if a plus b, if we know a, b, and c are integers, could we ever have 2a plus 2b equals 2c minus 1?
Well, no, because this is saying even plus even equals odd,
Ah,
because they're both integers.
okay. So this side has to be even because they're all integers. And this side is
Odd because it's 2 times something minus 1.
2 times an
It's
integer.
always odd.
Minus 1 is always odd. So this is called an even odd argument?
Yeah.
Or in math terms, it's called a parity argument. Okay? This has to be even, this has to be odd. And this parity argument is what we're going to see with, we're going to go back to Huron's formula. Okay?
All right.